So I'm going to launch right into the presentation that I want to give. How and why do we have clonal avocado trees? And then we will have a second talk presented by Xander Ernst and Consuelo Fernandez, building the foundation for a successful orchard, the nursery tree. So I'll launch into how and why do we have clonal avocado trees? And for the focus of my little presentation, we're going to focus on the hidden half of the tree, the roots. So the avocado industry in California started really commercially a little bit over 100 years ago in the early 1910s. And it was, there was a big interest in developing varieties for the industry. And in 1911, we have the Forte avocado was introduced into California by West India Nurseries and the Popenoe family. Also, this is a picture from 1911 by Wilson Popenoe of young avocado seedling trees being grown in the field prior to being budded. And so the focus was on seedling rootstocks. And very quickly, if you start reading the old Avocado Society yearbooks that's on Avocado Source, you'll see that there is a discussion that, you know, the ideal orchard needs to be uniform and productive. But with seedling rootstocks, you don't get that because avocados are what we call highly heterozygous. And heterozygous is a very fancy word for saying there's a lot of seed to seed variability on how they express their genetics. So even though you may go and collect all Zutano seeds, for instance, and plant out Zutano seeds, you will have a lot of variability in those seedlings because of this heterozygosity. And so it was noticed very early on in the late teens and early 20s that there was a lot of variability when you planted seeds to use as rootstock. And with root rot coming in the 1920s, you see starting being reported an avocado decline, which later ended up being root rot. And even in the 1930s, there were some researchers at UCLA and the Citrus Research Experiment Station at UC Riverside that were concerned about potentially salinity. And so the outcome, especially when you have seedling rootstocks, is that then you have great variability in the field in terms of how the trees respond to the environmental stress. So I'm going to talk very briefly about significant developments in avocado rootstocks. And so the need for new rootstocks was for uniformity of the fields, and then the discovery of avocado root rot and the search for resistance, which was led by George Zentmyer, who was hired in the early 1940s at UC Riverside. About the same time in Israel, the avocado industry was beginning. And in the late 1950s, 60s, and 70s, you have Avraham Bennikov from the Volcanic Research Institute looking for salinity tolerance. But there was a challenge here because they knew that you can't grow seedlings, and these traits are not inheritable at a very high rate. And so there was a great need to develop a clonal rootstock. So avocado root rot, as I mentioned, was noted in the 1920s. It was called avocado tree decline. And then in the early 1940s, the causal agent of avocado tree decline was identified as Phytophthora cinnamomi. And George Zentmyer was hired shortly thereafter. He was a plant pathologist. He was at UC Berkeley with a PhD in forest pathology, and he was hired at at Riverside. It was the experiment station at the time. And he began a very long career. You can see here 40 years of working on avocados and looking for a solution for avocado root rot. And in that process, he worked with many people internationally. He was very well known, and one of his a key collaborator was Eugenio Schieber, who was a coffee pathologist based out of Guatemala. And between the two of them, they searched high and low for wild avocados or avocados per se Americana in the marketplaces of Central America looking for resistance to Phytophthora. So in 1952, that's the first time you see an article by George Zentmyer in the California Avocado Society yearbook, and he talks about what the approach is that he's taking for solving the Phytophthora problem, and he outlined these five principles: nursery practices, cultural practices, biological and chemical control. They were a long way off at that time. And then he mentions the need for resistance and the need for clonal rootstocks. And this is a nice quote from one of his articles where he talks about that, just how catastrophic avocado root rot was. And when I was hired in 1983, a long time ago, avocado root rot was catastrophic. We're very lucky now that we have both rootstocks and chemical control and cultural practices that we can use to manage this disease. But back when George was hired, there was no alternatives. But there was a little bit of promise, because in 1955, he writes an article in the California Avocado Society yearbook saying that they finally have some promise to the root rot problem in the fact that they found seedlings of the Duke avocado having some tolerance to avocado root rot. But there was a big problem, and that was how to clonally propagate these trees. At the same time, we have Alhan Benikoff in Israel. He's looking for salinity tolerance. Again, he's finding a material in the 1960s and 70s that showed tolerance to salinity. But again, the big question is, how do you propagate this material? So the solution was a long time coming. We have the development of the etiolation process by Ted Froelich at UCLA. We have the commercialization of the cloning process by Hank Brokaw. And then we have the development of the microcloning process by Andre Ernst. So if we step back, Ted Froelich was a technician at UCLA. And in 1971, he and Bob Platt published a paper in the Avocado Society yearbook about the development of an etiolation method so that we could actually now clone avocados. But this was not an overnight success. In the 1930s, Halma and others published papers in the yearbook talking about their attempts to root avocados. They report that you could root juvenile tissue, but mature tissue was very difficult. And they report also that there is great variability in avocado varieties and able to root them. Froelich reports in 1951 the first partial success in rooting avocados by air layering. But it would take him another 20 years to publish the paper that changed everything in terms of avocado rootstocks. But the method they came up with was really not commercial. So the big question in 1971 is, how do you commercialize this process of etiolation? And step forward is Hank Brokaw from Brokaw Nursery. He modified the Froelich method. And in 1977, the first 4,000 trees, he writes in an article from the World Avocado Congress in 1987, he commercially produced the first clonal avocado trees on Duke 7. This Duke 7 is the one, remember, back in the 1950s, George Zentmyer is saying has tolerance to avocado root rot. So finally, we have some light at the end of the tunnel. You can see it took many, many years, multiple generations of avocado researchers and growers to come up with the advent of clonal rootstocks. If we fast forward then to 1999, we have Andre Ernst, who published a paper in the 1999 World Avocado Congress Proceedings from Mexico of his microcloning technique. And the microcloning technique differed significantly from the Brokaw method from the perspective that in the Brokaw method, you leave the nurse seed on the tree. And in the microcloning method, the nurse seed is removed in the nursery. So that is a major difference between the two methods. So the future and the present, clonal rootstock propagation opened the door for rootstock breeding. It opened the door for what the program is now, where we have multiple rootstocks now selected for disease tolerance. We have rootstocks now from Israel and elsewhere selected for salt tolerance. We can look down the road and say we need to select ones for cold tolerance, for dwarfing, etc. We're now really only limited by our imagination and ability to identify material that have different traits. And I see a time in the future, probably not too long from now, where we'll be able to have a variety of rootstocks similar to the citrus industry, where we can pick them for soil pH, for disease, etc. And that will greatly help the avocado industry. The new frontier in the future will be a tissue culture. We're not quite there yet, but sometime, I would say probably in the next 5 to 10 years, we will see tissue culture trees available. A lot of unknowns with tissue culture that we still need to solve, but it's definitely a part of the future. In the meantime, we still need to understand what constitutes a good tree and what you need to discuss with your nursery of choice and post-plant care. And so if we go back, we want the ideal orchard that is uniform and productive. The roots play a very important role in that. We know that the seedling orchard can be very non-uniform. It's more susceptible to root rot, salinity, and other stresses. And eventually what we want is the clonal orchard, where they're on a known rootstock that we know the characteristics. Now, it may not be completely ideal. We're working on that. Rootstocks are not, the rootstocks we currently have all have flaws, but the idea is that we're much more uniform than we were on a seedling rootstock.